Hi, this is your review for Unit 2, Activities 7 through 9. So we're going to cover all of the concepts that we went through in these activities. So just to again talk about what you should be studying, in Lesson 7.1 we solved quadratics graphically. So making sure you can do that. We also need to make sure that you can write a quadratic to model area. Part of that is being able to write expressions for length and width. Then we also need to be able to factor. So we solved factoring. We need to be able to solve quadratic inequalities. In Lesson 3, 7.3, we also wrote quadratic equations when we were given two solutions. Then we talked about solving quadratics. And we solved those 5 ways. So by factoring, we already talked about solving it graphically, which was another way up here. Then by square roots, completing the square, the quadratic formula. So these 4 and graphically are the 5 ways you need to be able to solve a quadratic. So once we have that, then we also talked about imaginary and complex numbers. So you need to be able to know what I and I squared represent. We need to be able to simplify, add, subtract, multiply, and divide complex numbers. Remember that for regular Algebra 2, the division you can do in your calculator. Honors, you need to be able to show work for doing that by hand. So those imaginary numbers, and then we also talked about the discriminant and how it can help you determine what type of solutions a quadratic has. So these are all the topics that we've covered over the past month or so. So if you're making sure that you are set and prepared for the embedded assessment and for the quest, again called that because it's bigger than a quiz, a little smaller than a usual test. These are the topics that you absolutely have got to know. So don't skip on these review problems. Make sure you go through and do all of them because these are the topics that it is slowly going through. All right, so we're going to start our review looking at number 2 first. It says in the introductory information that a rectangle has a perimeter of 40. And in number 2, it says, let the length of one side be x, then write a function a of x that represents the area of the rectangle. So writing a quadratic to model area here. So if we have a rectangle, we know that the perimeter is going to be 40. They also tell us that one of the sides is going to be x, so it doesn't matter what side we pick to be x. If this side is x, we know this side is x as well. The perimeter is 40, so we went through several problems like this in lesson 7-1, and then we revisited it later when we had a sum. We know that perimeter, it's going to be 2 of these plus 2 of these. So we know, and we've noticed a pattern with this type of problem, that the length and the width always have to add up to 40, so, or to half the perimeter, not always to 40. So here, half the perimeter is 20. So that means that my length plus my width has to equal 20. So if I've got x as my width here, x plus the length has to equal 20. So if I want an expression for this guy that involves x, all I need to do is subtract x from both sides. I see that this is going to be 20 minus x. And so then to answer number 2, my expression for area, it says a function, tells you what to name it. So a of x equals x times 20 minus x. So that would be our area expression there. You don't have to simplify that. It doesn't say standard form. If you do, it's also a correct answer, but this one right here is fine. So then number 3, it asks you to graph it on your graphing calculator and then sketch it on your grid paper. So it needs to be on your review problems as well. It says labeling the axes using an appropriate scale. Remember that you need to make sure that you adjust your window when you are graphing this on your graphing calculator. If you just pick some random values here, first of all, we know that the perimeter is 40, and so we know the length and the width have to add up to 20. This is the key to your x-axis. You know that you can't have a length or a width that's bigger than 20. So when you pick your scale on the x-axis, you want to make sure that your x maximum goes up to at least 20 in order to be able to see it on your graphing calculator. You can certainly try just a couple values of x to see maybe what an appropriate y scale would be. So if you look at this, and let's say that we just pick x equals 5. So if x equals 5, then we know that 20 minus x is 15. And so the area is going to be 5 times 15. So 5 times 15 gives us 75. So if I have 5 and 15, then I know that my area is going to be 75. So then if, say, I let x be 10, if x is 10, 10, and then this one is also 10, 10 times 10 is 100. So it seems to be that if I make my y max a little more than 100, it should be plenty big enough to see the entire thing. So again, picking that scale is very key to being able to see it on your graphing calculator. So certainly you can do that. Make sure your y max goes a little above 100. Make sure your x max goes a little above 20 so that you can see the entire parabola. So number 4 then says an area of 46 square centimeters is possible. Use a of x to demonstrate this fact algebraically and graphically. So if area, a of x, equals 96, it's saying to demonstrate that that's true. Well, when you graph it, here's 20 on my x-axis, and here's 100 on my y-axis, your graph looks something like this. So when it says to demonstrate graphically that this is possible, that just means to do something like this. To say, I can find 2 intersection points which represent the values of x, that would give me an area of 96. So graphically, that's what that means. Algebraically, that means it wants you to solve x times 20 minus x equals 96, because a of x equals this. So 20x minus x squared equals 96. So we're solving this quadratic equation here. So I usually want my squared term to be positive, so I'm going to move everything over where it's positive. So x squared minus 20x plus 96 equals 0 is what I'm trying to solve here. So we would always check to see if it's factorable first before we would look at our other algebraic. So I would look to see, is there something that multiplies to 96 that adds to negative 20? And there are negative 8 and negative 12. They multiply to positive 96. They add to negative 20. So that means this factors into x minus 8 times x minus 12. So if I'm solving by factoring, I get x equals 8 and x equals 12. So now I have demonstrated algebraically that yes, this area is possible because a width of 8 and a width of 12 make sense for the real life situation. Number 5 asks a very similar question, but it says an area of 120 square centimeters is not possible, and then asks you to do the same thing, algebraically and graphically. So graphically is super easy. All you have to do is show this. 120 is above the max, so it's not possible because you can't find any intersection points. Algebraically, you're going to set it up very similar to the way we set up this right here, that you're going to have 120 on the other side and you're going to solve that. Now, the way that you demonstrate that it's not possible is when you get your solutions, they have eyes in them. So you do need to actually solve it if you want to show the eyes, or you could also use the last thing that we learned in this particular half of the unit and use the discriminant. If you show that the discriminant is negative, then that means you have shown algebraically that the solutions are imaginary. So really two choices there. You can either solve x times 20 minus x equals 120, get the x's that have eyes and say this means it's not possible, or you can find the discriminant of that equation and say this means the solutions are imaginary, so that area is not possible. So several various choices there. All right, so we've talked about writing the model for area. We've talked about solving graphically because, again, that's when you find the intersection points. Remember that you can do that on your calculator by using the second trace menu, second trace intersect that we went over in class. Okay, so now we're going to talk about solving quadratics and factoring. So if we let's look at a couple plain factoring first. So let's start with number 13E, which is 5x squared minus 42x minus 27. So remember, factoring has a checklist that you need to follow. So first thing that you have to do is you have to look for a GCF. None of the other terms here are divisible by 5, so no GCF to take out here. Then you look for special products. This is a trinomial, so the only way it could be a special product is if it were a PST. PSTs have to have first and third terms that are both positive. This is not, so it can't be a PST, which means I go to step 3, which is chart factoring. So when I look at this, I can either do guess and check, split the middle, or I can use a box. So if I'm doing guess and check, my factors of 5 are 1 and 5. My factors of negative 27, remember the sign goes with it. I can have negative 27, positive 1. I can have positive 27, negative 1. I can have negative 3, positive 9. I can have positive 3 and negative 9. So when we do these by guess and check, I always say try the ones that are closest together first. So I'm going to try, obviously, the 5x and the 1x. I don't have any other choice. So I'm going to try the 3 and the 9 first. So I'm going to try, I'm just going to work from the bottom up. So I'm going to try a plus 3 and a minus 9. And then when we're guessing and checking, you FOIL it back out to see if it works. So first, 5x times x is 5x squared. Outsides, 5x times negative 9 is negative 45x. Then insides give me a plus 3x. Lasts give me negative 27. My inner and outers here give me a negative 42. Is that what I wanted? Indeed it is. So first try is our winner. This is the correct factorization. Now, if you're not a guess and check person, that means that the way you would start this one is by looking for what multiplies to a times c. So 5 times negative 27, which is negative 135, and adds to negative 42. So again, you're just going to have to try multiple things that multiply to negative 135 until you find the ones that are going to add to negative 42. So probably what I would look at first is 135 divided by 5. So 5 and negative 27, but that adds to negative 22. Because this is smaller than negative 42, that means I need these factors to be further apart. So I'm looking for something that's smaller than 5. So I would try 3, 135 divided by 3, and it does come out. So negative 135 divided by 3 is negative 45. So 3 and negative 45 is negative 42. So these are my winning numbers. Once you have your winning numbers, if you're a split the middle person, that means you're writing 5x squared. You're splitting this middle term into a plus 3x and a minus 45x, keeping the minus 27. And then you're going to factor by grouping. Group the first two, group the second two. GCF of the first group is just x, and I'm left with 5x plus 3. GCF of the second group, this is a negative, so I need to take out a negative, and the GCF is 9. So when I take negative 9 out, I end up with 5x plus 3, which is a good thing, because remember on split the middle, these need to match. So that means x minus 9, because those are my leftovers out in front here, times 5x plus 3. Notice again, same answer that I got by using guess and check. So then last method, if you're a box person on this, you start out the same way that split the middle people do. You find these winning numbers, but then you make yourself your box. So in your box, you put the quadratic term in the top left, 5x squared. You put the winning numbers, 3x and negative 45x, in these two boxes, and you put the constant term down in the bottom right. And then you do GCFs as well. So this row, GCF is x. This row, GCF is negative 9. Remember, you know that the GCF is supposed to be negative if the first term in that row or column is negative. So then I do columns. The GCF here is 5x. Then GCF here is 3. Again, I know it's a positive 3, not negative, because this term is positive. So then that means up here, 5x plus 3, x minus 9. So 3 different ways. Again, it's always your choice. You don't have to know all 3. You just have to know one. All right, so let's look at some solve by factoring here. Move it down a little bit. So let's look at, let's do 16c. So it starts out 4x squared minus 20x plus 25 equals 0. So solve by factoring. First you make sure it's equal to 0, which it is. Then you go through your factoring checklist. First I look for a GCF. First two are divisible by 4, but the third one isn't. So no GCF here. So that means I go to special products. It's a trinomial. So I look to see if it could be a PST. My checklist for PSTs, first and third both positive. Positive, positive, yes. First and third both perfect squares. Yes, yes. Square root of 4x squared is 2x. Square root of 25 is 5. Last thing to check on a PST is the middle term double the product of those square roots. 2x times 5 is 10x. 20x is double, so that means this is a PST. So that makes my life so much easier than having to do this that we did in 13E, because if it's not a PST, we'd have to guess and check, split the middle, or box it. Here, I know it's a PST, so I don't have to. Very simple. PST, square root of the front goes in the front, so 2x. Sine of the middle goes in the middle, minus, and then square root of the last goes last. So 2x minus 5 squared. So now it is factored. So to solve by factoring, I set each factor then equal to 0. So 2x minus 5 equals 0, and then I get x alone. So add 5 to both sides. That gives me 2x equals 5. And then I divide by 2. No decimals. The fraction's right here. X equals 5 over 2. Let's look at 16D as well. So 27x squared minus 12 equals 0. So it's already equal to 0. So that means next I go through my factoring checklist. Is there a GCF? Yes, there is a GCF. Both of these are divisible by 3, so I take that out. Leaves me with 9x squared minus 4 equals 0. Just because I factored once does not mean that I'm done factoring. I look at what's left. Next in my factoring checklist is special products. Since this is two terms, the only type of special product it could be is a difference of squares. So I look at it. To be a difference of squares, I have to have two terms separated by subtraction, which I do, and they both have to have perfect square roots, which they do. Square root of 9x squared is 3x, and the square root of 4 is 2. So this is a difference of squares. Difference of squares factors 1 with a plus, 1 with a minus. Square root of the front goes in the fronts, and square root of the back goes in the backs. So 3x plus 2 times 3x minus 2. So then I set each of those equal to 0. Subtract 2 here, 3x equals negative 2. Divide by 3, so I get x equals negative 2/3. And then over here, same number, different sign, because I get 3x equals positive 2. So then x equals 2/3. Now, I always get people here who, when they get to the first, after they take out the GCF, they then solve with square roots. If the directions say solve by factoring, that's not okay. If it just says solve, then that's fine, but you need to pay attention to directions. If it says solve by factoring, which this one does, you have to factor it. You can't go in and do a different method in between. All right, so next on our list, so we talked about solving by factoring. We talked about factoring by itself. We talked about this and this. So let's look at writing quadratics given to solutions. So an example of that is what we have in 17. So let's look at 17C, where they give you the solution x equals negative 7 over 5 and x equals 1/2. So remember that our first step here, we're working backward from solving by factoring. So the next thing I want to do is get these solutions equal to 0. Remember that when they're fractions, we have to do that in 2 steps. The first is to multiply by the denominator. So multiply by 5 here. That gives me 5x equals negative 7. And then add or subtract. So in this case, add. So I get 5x plus 7 equals 0. So done with the first one because I've got it equal to 0. Second one here, multiply by the denominator first, gives me 2x equals 1. Here, instead of adding, I subtract. to get rid of that 1. So I end up with 2x minus 1 equals 0. Once you have the equations equal to 0, now you're just going to multiply them. So if one of these equals 0, then their product has to equal 0. And the final step is to FOIL. So firsts give me 10x squared. Outsides, negative 5x. Insides, positive 14x. And lasts, negative 7. So combine the like terms in the middle, and that gives me 10x squared plus 9x minus 7 equals 0, which is my answer. I have now written a standard form quadratic when I was given the two solutions. All right, so next on our checklist, let's talk about solving quadratic inequalities. So that was lesson 7.4. So we're going to look at 23b. So I've got 3x squared minus 7x minus 6 is greater than 0. So remember that you get to choose. You can solve this algebraically or you can solve it graphically. It's your preference. If you are solving it graphically, then you're going to type this equation right here into your y1. You're going to adjust your window so that you can see the parabola. And then you're going to try to find the zeros by looking at the table, finding the x-intercepts, meaning where it crosses. So if you are solving this graphically, you get a picture that looks something like this on your calculator. And when you look at the table, you get a 0 right here when x is 3. So we know that one of the x-intercepts is x equals 3. Unfortunately, this one doesn't come out evenly because you can't see it in the table. It's not -1, and it's not -2, and it's not 0. So that means that we have to factor this in order to find the other exact value. So again, just like we reviewed here, there is no GCF here. It's not a special product because this is a minus. So we've got to either do guess and check, split the middle, or box. Again, it's your choice. Here, I'm going to choose guess and check because it's going to be faster. But again, your choice. You get to choose how you factor it. I know it's 3x and x because only one set of factors for prime numbers. Again, I'm trying these ones that are closest together. Minus 3 plus 2, that gives me a negative 3x and a positive 6x, so that'd be plus 3. So that doesn't work. So I am going to try them in the other order. So I'm going to try minus 2 here and a plus 3 here. So when I do that, I get 9x on the outside minus 2x on the inside. So that gives me inners and outers that combine to be positive 7x. I want negative 7, so that means I found the right numbers. I just now need to change the signs. So it's 3x plus 2 times x minus 3. So that means I know that this was x equals 3. Again, you can use that to kind of cheat on the guess and check if you want. This one's going to give you x equals negative 2/3. So now I know my other x-intercept. So if you're solving graphically, that means just look at the parabola. This is a greater than sign. So what's above the axis is the arrows. And we said whenever it's the arrows, that means we write an or. So either x is below the lowest x-intercept, which is negative 2/3, or x is above the highest x-intercept, which is 3. So less than negative 2/3 or greater than 3 if you're solving graphically. If you prefer the algebraic method, remember that that means you have to have this number line showing your x-intercepts and then what values you picked. So here you would probably pick -1. Here you would probably pick 0. Here, most people probably pick 4. But you have to plug those in to the original and show what they give you. This gives you a yes, this gives you a no, this gives you a yes, which again gives you an or because it's the arrows. Just another tip on 23C. This is something that we had on the extra credit. If you try to solve this graphically on 23C, your picture looks like this, and the symbol is a less than, or actually it hits the axis, sorry. It hits the axis here at 8, so x equals 8 is your only intercept, but then it's a less than sign. Absolutely none of the parabola is below. So that's why the answer is no solution graphically. Again, you could do it this way too. When you pick your numbers below 8 and above 8, neither of them work. So that's why that answer is no solution. Last one for activity 7. I'm going to get you started. If you had trouble on 24 through 26, it was a word problem. It gave you the function h of t equals negative 16t squared plus 20t plus 6, and it says models the height and feet of a football t seconds after it's thrown. So it wants you to write a quadratic inequality to determine when the football will be at least 10 feet above the ground. So that means when this is greater than or equal to 10. So in 24, all you're doing is taking h of t out and replacing it with this. So that's your quadratic inequality. 25, it just wants you to get it in standard form. So we've done this before, several problems in our lessons. First, you have to subtract the 10, which gives you negative 16t squared plus 20t minus 4 is greater than or equal to 0. But in standard form, remember, this has to be positive. So that means we need to divide everything by negative 1. When you do that, that becomes positive 16t squared minus 20t plus 4. When you divide by a negative, you have to flip the symbol. We had one just like this in our homework problems. So then this is the trick to being able to solve. 26 then is just exactly the same as what we did here in 23b. You can either solve it graphically or you can solve it algebraically. But the key here is that this sign flipped. So if you want the right part of the parabola, you have to remember to flip that sign. All right, so let's move on to activity 8, which is where we started talking about imaginary numbers. So we're going to check that off of our list and talk about those. So most simple thing is making sure that you know that I stands for the square root of negative 1 and that I squared is negative 1. So being able to simplify, that's important. So we're going to look at 1c for that. 1c, you had negative 7 plus or minus the square root of negative 12. So if you were simplifying this and writing this in a plus bi form, which means that I need to take this negative out. So plus or minus I radical 12 is my first step. Then, if I want it to be in simplest form, I need my radical simplified. So 12, if I factor tree it, is 4 times 3, 2 times 2. So I've got a 2 that gets to go to the matching outfit party. A 3 that has to stay on the inside. So radical 12 becomes 2 radical 3. Remember that when we have the I, it goes between. So 2I radical 3. Do not do anything else here. This negative 7 is not a like term because it doesn't have the same radical. So this is all that we can do here when we're simplifying. Number 6 wanted you to graph the various imaginary points that you had. So it gave you A, B, C, D, and E, and it wanted you to name the complex number that goes with it. So just remember that when you're looking at the graph, this is the real axis, and this is the imaginary axis. So if we look at, let's say, A was located in this position right here. So the real, we went to the left, which means that it's a negative real number. So that gives us -3. Oops, I'm looking at the wrong one. I'm so sorry. I was looking at 8, which is not what we had. So this one actually asked us to graph them. Sorry about that. So in 6, you're drawing your complex plane just like this, and then you are actually graphing it. So if we look at, let's look at C then, sorry, since I was looking at the wrong problem. It wanted you in C to graph -3 minus 4i. So the real part is negative, that means go to the left 3. The imaginary part is also negative, so that means go down 4. So your location of A, or C, sorry, can't stay with it here. Your location of C, which was -3 minus 4i, would be right here. And you follow the same pattern for all of 6 then. Next thing we need to make sure we can do is perform the operations with our imaginaries. So I'm going to look at number 9D, which was -5 plus 4i minus 7/3 plus 1/6 I. So because this is subtraction, my first step should be to distribute the negative. So distribute my negative. I don't need to change the first ones, just these second ones. So now I identify and combine like terms. Here are my like terms. So because these second ones have fractions, that means you need a common denominator. So right now, this is -5/1. If I want that to become a 3 in the bottom, that means I multiply the bottom by 3 and I multiply the top by 3. So that's -15/3 minus 7/3 that I have for my real parts. Then for my imaginary parts, this denominator was 6. So if I want this to have a denominator of 6, I multiply by 6. And so then that gives me 24/6i. And this is a -1/6i for those like terms. So combine them. -15 minus 7 gives me -22. When I add and subtract fractions, the denominator stays the same, so it stays a 3. Here I have +24, -1, which gives me a +23/6i. Final thing I would do is to make sure they don't reduce, which in this case they don't, so that is my final answer. So that's our subtraction there. Then I want to look at multiplication. So if we look at multiplication in number 10 here, if we look at 10D, you've got 8 minus 3i times 4 minus 2i. So foiling is how I'm going to begin here. So firsts, 32. Outsides, -16i. Insides, -12i. The signs are so important, guys. Lasts, negative times a negative is a positive, so +6i squared. Don't forget the squared. So now, second step when I FOIL with imaginaries is to substitute -1 in place of my I squared. That's one of the things I need to know. So this becomes a -6. So now these guys are like terms. 32 minus 6 gives me 26. And then these are like terms in the middle. -16i minus 12i gives me -28i. Now, honors people, you need to know how to do division. And I didn't put one in there. If you want to look at a couple examples to make sure, you could look at 11C and D. Remember that for those, you multiply the top and bottom by the complex conjugate. So For example, on 11D, which looks like this, you would multiply the top and bottom by 3 plus I. It has to be different sign from the bottom. So you'd FOIL the top, FOIL the bottom, and then simplify. The answer to that one, if you want to try one and make sure you get the right answer, should look like this. Again, regular, you can use your calculator on that. All right, so we've talked about imaginaries. We can check that off. So next thing, if I go back and look up at what is left, solving quadratics via my other method. So let's look at solving by square roots next. So an example of that one, we're going to look on the page 149 and 150 because we're into activity 9 now. So number 3 had 9x squared minus 32 equals 0. So to solve by square roots, I need to isolate the squared term first. So that means I'm going to add 32 to both sides. 9x squared equals 32. Still not alone yet. I need to divide by 9. So x squared equals 32 over 9. Once my squared term is alone, then I take the square root on both sides. So on the left, the square root and the squared undo each other. On the right, whenever I solve with square roots, I have to put in a plus or minus. So plus or minus square root of 32 over the square root of 9. Step 3 is to simplify my radicals. So on the top, square root of 32 doesn't come out evenly, but 32 is 8 times 4. This is 2 times 4, 2 times 2, 2 times 2. So I've got matching outfit here, matching outfit here. So a 2 times 2 gets to come to the outside. So 4 on the outside. On the inside, just a 2 stuck on the middle. Bottom, square root of 9 is easy. It comes out evenly. It's 3. Sorry, I made my thing a little too long here, although it really doesn't matter. So plus and minus 4 radical 2 over 3 is my answer there. Let's look at one more with solving by square roots. So let's look at number 4, where we've got x plus 4 squared minus 25 equals 0. So this right here is my squared term. So to get it alone, I need to add 25 to both sides. So x plus 4 squared equals 25. Squared term is alone, so I'm going to square root both sides. X plus 4 on the left, plus or minus square root of 25 on the right. Next, simplify the radical. Square root of 25 comes out evenly, so plus or minus 5. Final step here is to subtract the 4. So remember the plus or minus is attached to the 5. Keep it there. Negative 4 plus or minus 5. Don't leave your answer like that. These are now like terms. So negative 4 plus 5 would give me x equals 1. Negative 4 minus 5 would give me x equals negative 9. So x equals 1 or x equals negative 9 are my two answers there. All right, so next we want to look at solving by completing the square. So an example of that one, we'll look at two different ones here. So we'll look at 16 first. So x squared minus 10x equals 26 was my original here. So first thing I have to do is make sure that my constant term is on the right, which it is. So x squared plus bx on the left, c on the right. Next, I factor out the a term. Well, a is just 1, so remember you don't have to write the 1. For those of you who prefer to, I'm writing it for you, but you do not have to write this 1. After you factor out the a, the next step is to add some blanks. So on the left, my blank goes inside the parentheses, and then I need one on the right as well. We fill in the parenthesis the same way every time. B divided by 2 squared. So here my b is negative 10 divided by 2 squared. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. That's my blank on the left. Blank on the right, we do the multiplication, and it's going to be 25 as well because this is a 1. Next, we factor the left side as a PST. So PSTs factor the same way every time. Square root of the front is x, sine of the middle is negative, square root of the third is last, and then I get a squared. 25 plus 26 is 51 on the right. Now, I can solve with square roots. So, square root the left, square root the right. X minus 5 on the left equals plus or minus the square root of 51. So then I would try to break down and simplify my radical. 51 is divisible by 3. It's 3 and 17. These are both prime. Nobody has a matching outfit, which means I have to leave it like this. So then just add my 5. I've got x equals 5 plus or minus radical 51 for my answer. Let's look at one more completing the square. We'll look at 17 as well. That's x squared plus 5x minus 9 equals 0. So first thing I have to make sure is that my constant is on the right. In this case, it's not, so I need to move it by adding. So x squared plus 5x equals 9. Then I'm going to factor out my a. Again, you don't have to write the 1 if you prefer to, that's fine. Then add your blanks. Here, b divided by 2, 5 divided by 2 squared. 5 divided by 2 doesn't come out evenly, which means this is a case where I'm going to have a fraction. So square the top, 25. Square the bottom, 4. So 25 fourths. Because this was a 1, the right side blank is going to be the same. So now factor as a PST. Just because it's a fraction doesn't mean we do it differently. Square root the front, sine of the middle, square root of the back, which is always your b divided by 2. So 5 halves squared equals 9 plus 25 over 4. You can add those by getting a common denominator. Again, you have a calculator, so you're also allowed to use your calculator to add those. Either way, you should get 61 over 4. We don't use decimals. So then, squared term alone, so square root both sides, gives me x plus 5 over 2 over here, plus or minus the square root of 61 over the square root of 4 over here. Next, simplify my radical. Square root of 61. 61 does not have any perfect square factors, so I can't do anything to it. I can, of course, simplify this. So I've got x plus 5 halves equals plus or minus the square root of 61 over 2. So then my final step is to subtract the 5 halves. So remember to keep the plus or minus attached to where it was originally attached to. So plus or minus radical 61 over 2. And so these would be my answers here. Okay, so we have solved with square roots. We have solved by completing the square. So we're almost done, just the quadratic formula and the discriminant left to talk about. So let's look at an example of using the quadratic formula. First of all, must know the quadratic formula. It's so sad to me when we get to this question on the test and people are missing it because they didn't take the time to memorize it. The quadratic formula, x equals plus the opposite of b plus or minus the square root of b squared minus 4ac, the whole thing divided by 2a. Do not just put it under this part. It's the whole thing. All over 2a is how the song goes. YouTube the song if you need to get it in your head. Okay, so these are my solutions for the quadratic formula. So looking at a problem where I'm going to solve using the quadratic formula, I'm going to look at, let's look at number 21. So 21 was x squared plus 12x plus 6 equals 0. Remember, it has to be equal to 0 first. So on number 23, it's not what I'm going to do on here, but make sure you subtracted the 25 first on 23 because it's got to be equal to 0 first. So then identify my A, B, and C. A is 1, B is 12, C is 6. I think that doing this reduces the chance of you making a mistake when you're plugging things in. So now use the formula, the opposite of B. So negative 12 plus or minus the square root of B squared. 12 squared is 144 minus 4 times A, which is 1, times C, which is 6, the whole thing divided by 2 times A. So again, the more work you can show, the more possibility there is for partial credit. We simplify these the same way every time. We do the 4AC first because order of operations says this multiplication goes first. So I've got 144 minus 4 times 1 times 6 is 24. Bottom, the multiplication gives me 2. So now I need to do what's inside the square root. 144 minus 24 gives me 120. Now I need to break down my square root here. If we're factor treeing it, again, there's lots of different factors for this. So if I look at it and I say, okay, 120 divided by 4 is 30. So 4 and 30. 30 is 6 times 5. 4 is 2 times 2. 6 is 2 times 3. So for the matching outfit party, I've got a 2 that gets to come out. The rest of what's left, no matching outfits. So 2 times 3 times 5, which is this entire 30, has to stay underneath. So when I look here, I'm going to move it over here. Negative 12 plus or minus, the 2 got to come out. So 2 radical, 30 had to stay in, over 2. Now, final step here. You can do this one of two ways. You can simplify it like we do A plus BI form and do negative 12 over 2 plus or minus 2 radical 30 over 2 and then simplify, which this is going to give me negative 6. This right here, the 2's cancel, and I get radical 30. So that's one way to do it to get that final answer. The other way is to look and say that all 3 terms are divisible by 2. So 2 divided by 2 is 1, 2 divided by 2 is 1, negative 12 divided by 2 is negative 6, and then write this final answer that way. So either way, you should come up with the same answer. All right, we're moving right along. We're almost done. I know this has been long, but hopefully you found the review helpful. Last thing we need to talk about is the discriminant. Again, makes it really hard to solve the problem if you don't know what the discriminant is. So the discriminant, remember, is b squared minus 4ac. It's the part of the quadratic formula that's under the square root. So your discriminant problems were 38 through 41, the last 4. All it asks you to do is to find the discriminant and then to tell what that what type of answers that's going to give you. So when we look at the discriminant for, let's do 39 here. So when we're looking at the discriminant for number 39, which that problem was 9x squared plus 30x plus 25 equals 0. So it's already an equals 0 form. So I know my A is 9, my B is 30, my C is 25. So I'm going to do B squared, 30 squared, minus 4 times A, which is 9, times C, which is 25. So 30 squared is 900, minus 4 times A times C, which is 900, gives me 0. Again, We did the chart on the discriminant. Really, really important. It's on page 146. You have to study that. So the discriminant there is 0. So the first part of the answer is 0, but that's not the only part. You have to tell what that means. That means one real rational solution. We call that, again, a double root. So one real rational. So look over the chart that we filled out on page 146, because you need to know if the discriminant's negative, that means that there's two complex conjugate solutions. If the discriminant is 0, one real rational. If it's positive and a perfect square, that means that there's two real rationals, and positive, not a perfect square, two real irrationals. So I gave you an example of each in your review problems. All right, so make sure you've gone through anything that you really struggled with here. Now you've heard another explanation. Maybe go back and do an extra. Pick one of the problems to do again if you need to. Really important that you know all of these concepts for your embedded assessment and for your test. That's it. Happy studying.